Hi friends! Today we are going to talk about suspend functions and why they're so awesome. Today's video will be different from the previous ones because today I have Ksenia who knows nothing about coroutines. Hey, my name is Ksenia and I know nothing about coroutines. But the word sounds like food, so I hope I'll get fed here. I wouldn't count on that. Wait, hold on. Don't leave, we will feed you. But you need to learn this topic really well, okay? No. Well, that's great! Let's get started! First, let's figure out what a suspend function is. A function, as we know, is a block of code that performs a specific task. In simple terms, you can think of a function as a recipe. It takes some ingredients, input, follows certain steps, code, and gives you a result, output. However, sometimes function doesn't produce any output at all. It simply performs an action. Functions execute from start to finish and only then return control to the code that called the function. I don't understand anything. What control? You're right, let me explain a bit more simply. Imagine regular code. In this code there are classes, variables, objects, and functions. But how does the compiler execute this code? When the compiler starts running the code, it begins with the first line. If it encounters a function, it does the following. First, the compiler stops executing the current line of code. Then, it jumps to the function code and starts executing it. This is where a stack comes into play. So stack is a data structure that stores information in a last in, first out manner, meaning the last item added is the first one to be removed. It's different with the queue, right? Where the first element in will be first out. Again, and stack is last in, first out. For example, think of a stack of plates. You can only add or remove the top plate. So the last plate you put on the stack is the first only you'll take off. The stack is the place where the compiler keeps track of information about which function was called and where it needs to return after executing that function. When a function begins, the compiler adds a record of the current place, the address, from where it came into the stack. After the function runs from the start to finish, the compiler looks at the top of the stack, finds the address it needs to return to, and goes back there. This means it continues executing from the line where it left off, as if nothing had happened. It's important to remember the functions always execute from beginning to the end, and only after they're finished does control return to the code that called this function. So if I have a function called trim_tree, which inside calls a function find_penguin, then the trim function will be paused and the compiler will switch to executing the entire find_penguin function. That's right, very good! Although I won't lie, that's a bit of a strange example. What if my find_penguin contains other functions, like scratch leg? In that case, the find_penguin function will also be paused. And first the function, and I can't believe that I'm saying this, scratch leg will be executed. The pause function will be added to the stack, and we will definitely return to them once we finish the current function. Got it, but what does asynchronous programming have to do with this? That's a good question. The thing is, sometimes our functions can give us an answer right away. For example, if we have the function that adds two numbers, we get the answer almost instantly, and our thread moves on to the next part of the code. But what if our function makes requests to the server? What kind of request? The number of legs that need scratching? Your examples are a bit concerning, but okay, yes. We make requests to the server, but we can't get response immediately. So we wait. And while we wait for the response, our thread is blocked and can't do anything else. We're just wasting our resources on ordinary waiting. What should we do? Not call this function at all? No, that's silly. I can't believe I'm saying this. But our user really needs to know the number of legs that need scratching. so we must make the request. However, to optimize resources, we can use the wonderful approach of the coroutines, suspend functions. A suspend function is a special type of function in Kotlin that can pause its execution and wait for something to finish, like a network request. When it paused, it doesn't block the entire program. It just gives control back to the code that called it. So, how does it happen? Good question. When you call a suspend function, it gets added to the call stack, just like any other function. But there is a cool part. If it needs to wait for something, like a server response, it can suspend itself instead of blocking the entire thread. When a suspend function suspends, it saves its current state, which means it remembers where it left off. This state is kept in memory, allowing the program to do the other tasks while waiting for the response. Once the data is ready, the function picks up right where it left off and continues executing. But how does the program know when to resume it? Behind the scene, Kotlin used something that's called a coroutine. Coroutine manage all suspend functions and ensure they resume in the right time. When the operation, the function, is waiting for its complete, the coroutine wakes it up and lets it continue. So the program can do other things while it waits? Exactly! That's why suspend functions are so powerful. They help keep the application responsive. For example, while waiting for the server response, the app can still process user inputs or perform animation. They make asynchronous programming much easier and help avoid the dreaded callback hell. By using suspend functions, we can write code that looks and behaves like regular synchronous code, but with efficiency of asynchronous execution. How do I write suspend function? It's very simple. You just need to place suspend modifier before the function declaration. And that's all you need. And I can call this function anywhere? Not exactly. You can only call a suspend function inside a coroutine, because only coroutines know how to properly handle suspend functions. So what exactly is a coroutine? A coroutine is a lightweight thread, like a construct that allows you to write asynchronous code in sequential manner. It lets you perform long-running tasks without blocking the main thread, making your application more responsive. How to create a coroutine and more about that we will discover in the next videos. Thank you and take care. Bye!